Hello students, let's do playing with numbers exercise 3. Question 1. Find the HCF of the following numbers. Now what is HCF? Highest common factor. And we've been given numbers here. So we have to write the factors of 18 and the factors of 48. Pick out all the common factors and from that take the highest common factor. Now there are different methods of doing it. Okay, now here we're going to use the prime factorization method to find the first the factors of 18, then the factors of 48, then we're going to look out for the common factors. Remember, common factors, highest common factor. So let's begin by finding the prime factors of 18. So let's begin with this. Now we have 18. We can divide this by 2. Remember, we're going to use prime factors. 2 9s are 18. Now we have 9. We can't use 2. We'll go to the next prime number, which is 3. 3 3s are 9. Then we continue again. 3 1s are 3. So you continue till you get 1. So now we have all the prime factors of 18. That is 2 into 3 into 3. These are the prime factors of 18. Now, in the same way, we have to find the prime factors of 48. So let's do that. So let's write 48. And again, here also we'll begin with 2. 2 2s are 4. 2 4s are 8. That means 2 into 24 is 48. Continue with 2. 2 into 12 is 24. Again, we're going to continue with 2. 2 6s are 12. Again, use 2. 2 3s are 6. This time use 3. 3 1s are 3. So we've got all the prime factors of 48. How many 2s are there? 1, 2, 3, 4 2s. So let's write that down. So we have 48 and all the prime factors of 48. 1, 2, 3, 4 2s, and then we have a 3 also. So these are the prime factors of 48. Now we have to look for the common factors. That means what are the factors that are here as well as here? It should be there for both. So here we have a 2 and here we have a 2. That means this is common. So let's circle that. So this is common. Now let's go to 3. We have a 3 here and a 3 here. So these two are common, or you can take even this 3. So let's do that. So we have a 3 here and we have a 3 here. So we have 2 and 3. Now, is there anything else common? We have one more 3, but we don't have any more 3s. And here we have 2s, but we don't have a 2 there. So the common factors are 2 into 3. So now we can find the HCF. The HCF of 18 and 48 will be 2, which we have circled, and 3, which is common. So 2 3s are 6. So the highest common factor of 18 and 48 is 6. And we have used the prime factorization method. Question 2. Again, we have two numbers, 30 and 42. We have to find the HCF of 30 and 42. So first, the prime factors of 30. So let's find the prime factors of 30. So let's write that down. 30. We can use 3 itself. 3 10s are 30. Now we can use 2. 2 5s are 10. This time we have 5. Let's use 5. 5 1s are 5. So all these numbers that we have used, 3, 2 and 5, are prime numbers. So let's write down all the prime factors of 30. That is starting with the smallest number. Okay, so 2 into 3 into 5. Now let's find the prime factors of 42. So let's begin with 42 now, and let's start with 2. 2 2s are 4, 2 1s are 2. We have 21. I cannot use 2 anymore, so I'm going to use 3. 3 7s are 21. Now 7 can be divisible only by 7, which is also a prime number. So 7 1s are 7. So what are the prime factors of 42? 2 into 3 into 7. Now let's see what is common here. Okay, so as you can see, we have 2 that is common. 2 is common. And we can also see 3 that's common. So let's circle 3 also. So 3 is also common here. So now what is the HCF of 30 and 42? That will be 2 into 3. 2 3s are 6. So here the HCF of 30 and 42 is also 6. Question 3, 18 and 60. Let's find the prime factors of 18. So here let's begin now with 18 and we'll start with 2. We can start with 2. So 2 nines are 18. Now we'll go on to 3. 3 threes are 9. Continue with 3 again. 3 ones are 3. So what are the prime factors of 18? 18 we have 2 into 3 into 3. Now let's go on to 60. Let's find all the prime factors of 60 beginning with 2. 2 threes are 6, so 2 into 30 is 60. I can take 3 now. 3 tens are 30. Now again I can go back to 2. 2 fives are 10. Now I can use 5. 5 ones are 5. So what are the prime factors of 60? The prime factors of 60 are, first let's take all the 2's. There are 2 2's. So 2 into 2. Then there is a 3 and there is a 5. Now what are the common factors? 2 is common. As you can see, there's 1 3 that's common. Now here there is one more 3, but we don't have 3's here. And here we have a 2 and a 5 and we don't have it there on top. So these are the only two common factors. So the HCF of 18 and 60 will be 2 into 3. 2 threes are 6. So here also our answer is 6. Question D. Let's find the prime factors of 27 and 63. So 27 will begin now. We can start with 3. 3 nines are 27. Continue again with 3. 3 threes are 9. Again with 3. 3 ones are 3. So what are the prime factors of 27? We have 3 threes. 3 into 3 into 3. Now let's take up 63. Now this 63 we can divide with 3. Let's start with that. 3 twos are 6. 3 ones are 3. Again we can divide 21 by 3. 3 sevens are 21. This time use 7. 7 ones are 7. So what are the prime factors of 63? 3 into 3 into 7. Now what is common? As you can see, there's one 3 that's common. There's one more 3 that is common. So there are two 3's that's common. Now here we have one more 3, but we don't have a 3 here. Here we have 7. We don't have a 7 there. So let's write down the HCF. HCF is equal to 3 into 3. 3 threes are 9. So the HCF of 27 and 63 is 9. Next one, we have 36 and 84. So let's find the prime factors of 36 first. So let's write that 36. We can begin with 3 here. 3 ones are 3, 3 twos are 6. Continue again with 3. 3 fours are 12. Now I can use 2. 2 twos are 4. Again 2. 2 ones are 2. So the prime factors of 36 will be starting with 2. 2 into 2 and then 3. 3 into 3. Now let's get the prime factors of 84. So 84, we can begin with 2. 2 fours are 8, 2 twos are 4. Again, I can continue with 2. 2 twos are 4, 2 ones are 2, 21. This time I'll use 3. 3 sevens are 21. Now I'll use 7. 7 ones are 7. So we have used only prime numbers. 84, the prime factors are 2 into 2 into 3 into 7. Now what are the common ones? I can see 1 2 here and a 2 here. One more 2 there and a 2 here. There's a 3 there and a 3. So these are 3 common factors. So let's circle them. So now 2 and 2 and 3 are the 3 common factors. Now let's find the HCF. So HCF will be 2 into 2 into 3. So let's multiply. 2 twos are 4, 4 threes are 12. So the HCF here is 12. The HCF of 36 and 84 is 12. Question F, we have 34 and 102. Let's find the prime factors of 34 first. 34. Now I'll begin with 2. 2 ones are 2. Now here the number is 3, isn't it? I'm doing short division. 2 ones are 2, 3, there's 1 left. So now the number is 14. 2 into 17 is 14. Now what can I divide 17 with? I need to think of a prime number. I can only divide it by 17 itself. So 17 ones are 17. So the prime factors of 34 will be 2 into 17. Now let's find the prime factors of 102. So 102, this time also I'm going to use 2 because it's an even number. I can divide it by 2. 2 is a prime number. Now let's take 10. 2 5s are 10. Then we have 2. 2 1s are 2. Now what can I divide 51 with? I can divide it by 3. Okay, so 3 1s are 3, 4 5, there is 2 left, so the number is 21. 3 7s are 21. Now I have 17, which is divisible only by 17. 17 ones are 17. So what are the prime factors of 102? The prime factors are 2 into 3 into 17. So let's look out for the common ones. Now 2 is common, and we also have 17 that's common. So there are two factors that are common. Let's circle those. So we have circled 2 and 17. That means our HCF will be 2 into 17. 2 into 17 is 34. So the HCF here of 34 and 102 is 34. This time we have three numbers 70, 105, 175. So just like the previous one, first find the prime factors of all these numbers and then find the HCF. So again we are using the prime factorization method. So let's begin. Let's find the prime factors of 70. Let's begin with 5. 5 ones are 5. Now there is 7 there, 6, 7, that is 2. So the number becomes 20. 5 fours are 20. Now I can use 2. 2 sevens are 14. Now I can use 7 itself. 7 ones are 7. So the prime factors of 70, let's write it down. Starting with 2 into 5 into 7. Now let's find the prime factors of 105. So 105, let's divide this by 5. Let's take 10, 5 twos are 10, then we have 5 ones are 5. Now take 3, 3 sevens are 21. Now continue with 7, 7 ones are 7. So what are the prime factors of 105? 3 into 5 into 7. Now let's take 175 and find the prime factors of 175. Again, let's use 5. Take 17. 5 threes are 15. 16, 17. There is 2 left. Now the number is 25. 5 fives are 25. So here again, let's take 5. 5 sevens are 35. This time let's take 7. 7 ones are 7. Let's write down the prime factors of 175. The prime factors are 5 into 5 into 7. Now what are the common factors? This time it should be common to all three numbers. Now here we have 2. Do we have 2 here? No, we don't have 2 here also. Now let's take 5. Is it common? Yes, we have a 5 everywhere. So 5 is common. Similarly, 7 is also common. So 5 and 7 are common. So what is our HCF? Our HCF will be 5 into 7. So we're multiplying the common ones. 5 sevens are 35. That means the HCF of 70, 105 and 175 is 35. Question H. So here also we have three numbers. So let's begin with 91. So 91, which is a number that can divide 91 completely. We have to think of a prime number. Now 91 is divisible by 7. 7 ones are 7, 8, 9. There is 2 left, so that's 21. 7 threes are 21. So we've got 13. And 13 is divisible only by 13 itself. It's a prime number. So 13 ones are 13. So 91, the prime factors are 7 into 13. Now let's find the prime factors of 112. So 112, we can begin with 2 because it's an even number. So let's take 11. So 2 5s are 10 and there is 1 left. 11, isn't it? So there's 1 left. It's become 12 there now. So 2 6s are 12. Now continue again with 2. 2 2s are 4. 5. So there's 1 left and the number is 16. 2 8s are 16. Continue with 2. 2 1s are 2. 2 4s are 8. 14. Again, 2 7s are 14. This time we can do it with 7. 7 1s are 7. So what are the prime factors of 112? Write all the 2's. There are 4 2's. 1, 2, 3 and 4, and then we have a 7. Okay, now let's take the third number, which is 49. Now 49 can be divided only by 7. 7 sevens are 49, so divide 7 again. 7 ones are 7. So what are the prime factors of 49? 7 into 7. Okay, now let's look out for the common factors. We have a 7 here. Here also we have a 7. Here also we have a 7. So 7 is common. Then we have 13, which is not common anywhere. So it's only 7. So that means 7 here, then this 7, and you can take any one of these 7. So we have 7 that is common. That means it's easy here. We don't have to multiply. We just have to say the highest common factor is just 7. So we've got our answer. Highest common factor of 91, 112 and 49 is 7. Question I. We have three numbers 18, 54, 81. Let's find the prime factors first of 18. So 18 we've done before, so it's easy. Let's begin with 2. 2 nines are 18. Then 3. 3 threes are 9. Then again 3. 3 ones are 3. So what are the prime factors of 18? Prime factors of 18 will be 2 into 3 into 3. So we've got the prime factors of 18. Let's get the prime factors of 54. So 54, again it's an even number, so we can divide it with 2. 2 twos are 4 and there's 1 left, so that's 14. 2 sevens are 14. Now take 3. 3 nines are 27. Continue with 3. 3 threes are 9. Again 3. 3 ones are 3. So what are the prime factors of 54? So we have 2 into, we have 3 threes, 1, 2 and 3. Now let's find the prime factors of 81. So we have 81 and we can divide this by 3. 3 twos are 6 and then 7, 8. There is 2 left, so the number is 21. 3 sevens are 21. Now continue. 3 nines are 27. 3 threes are 9. 3 ones are 3. So now the prime factors of 81 are all 3's and there are 4 3's. Let's write it 1, 2, 3 and 4. There are 4 3's. Now what is common? We have 2 and 2, but here we don't have a 2. So 2 is not common. Let's take 3. Yes, we have 3's here. We have one more 3 here. So let's circle that. So we have circled the 2 3's. That means our HCF is equal to 3 into 3. 3 3's are 9 and this is our answer. The HCF of 18, 54 and 81 is 9. Question J. So let's start by finding the prime factors of 12. So 12, we can begin with 2. 2 sixes are 12. Then we'll continue with 2. 2 threes are 6. This time let's use 3. 3 ones are 3. Now the prime factors of 12 are 2 into 2 into 3. Now next we're finding the prime factors of 45. So 45, we can begin with 3. 3 ones are 3. There's 1 left, so that's 15. 3 fives are 15. Now we have 15, we continue. 3 fives are 15. Now we'll continue with 5. 5 ones are 5. So the prime factors of 45 will be 3 into 3 into 5. Now let's find the prime factors of 75. 75, let's begin with 5. 5 ones are 5, 6, 7, 2. So that's 25. 5 fives are 25. We'll continue with 5. 5 threes are 15. Now we can divide by 3. 3 ones are 3. So what are the prime factors of 75? The prime factors are, beginning with 3, 3 into 5 into 5. So let's see what is common. We have a 2 here, but we don't have 2's here. So let's take 3. We have 1 3 here, 1 3 here and 1 3. Yes, so 3 is common. Then we have 5 here and here, but we don't have 5 there. So we only have 3 that is common. So 3 is the only one that is common here. So let's write our HCF. Our HCF here is 3. So this is our answer. So the HCF of 12, 45 and 75 is 3. Question 2. What is the HCF of two consecutive numbers? Consecutive means numbers that come one after the other. Like 1, 2, 3, 4, 5. When you take any two that come after each other. It is 2 and 3, 3 and 4, 4 and 5. They're all called consecutive numbers. Now let's take 2 and 3. So let's take two consecutive numbers 2 and 3. Let's find the HCF of 2. Let's write down all the factors of 2. That is, what are the numbers that multiply to give us 2? 1, 2's are 2. So 1 and 2 are the factors of 2. What are the factors of 3? 1, 3's are 3. So 1 and 3 are the factors of 3. Now what are the common factors here? The common factor, as you can see here, is only 1 because 2 is not common. 1 is common. So 1 is the only common factor and the highest common factor is 1. This is the only one that's there and that is the highest common factor. So what is the answer to this question? What is the HCF of two consecutive numbers? The HCF of two consecutive numbers is 1 as we have found out. Next question. What is the HCF of two consecutive even numbers? Even numbers are numbers like 2, 4, 6, 8, 10, 12. All these are even numbers. Let's take any two even numbers. Let's take 2 and 4. These are two consecutive even numbers. Consecutive means that come one after the other. Now 2, 4, 6, 8, 10 and so on are all even numbers. Consecutive means that come next to each other. So I took 2 and 4. You can take 4 and 6 or 6 and 8, 8 and 10 or anything. So here we have taken 2 and 4. Now let's write all the factors of 2. All the factors of 2 are 1, 2's are 2. So 1 and 2. Let's write all the factors of 4. So we know 4, what are the factors? 1 into 4 is 4. Then we know 2 2's are 4. So what are the factors of 4? 1, 2 and 4. We don't have to repeat this 2. So let's write the factors of 4, 1, 2 and 4. Now here let's pick out the common factors. The common factors are, I can see 1 here that's common. So let me write 1. Then we can also see 2 that's common. So 2 is also common. 1 and 2 are common. Now in this, pick out the highest number. Which is the highest number? 2 is the highest number. So 2 is the highest common factor. So what is the answer to this question? What is the HCF of two consecutive even numbers? The answer is the HCF of two consecutive even numbers is 2 as we just found out. Next question. What is the HCF of two consecutive odd numbers? So let's write down a few odd numbers. 1, 3, 5, 7, 9, 11. All these are odd numbers. We can take any two consecutive. That means that come one after the other. So let's take 7 and 9. Let's take 7 and 9 and find all the factors of 7. 7 will be, what are the numbers that give us 7? 1 7's are 7, so only 1 and 7. Now let's take all the numbers that give us 9. 1 9's are 9. Now here let me write it down. 1 into 9 is 9. What else will give us 9? 3 3's are 9. So what are the factors of 9? 1, 3 and 9. We need not repeat the 3. So let's write 1, 3 and 9. Now let's write all the common factors. What are the common factors? As you can see, there is 1 that is common. 7 is there, it's not here. And none of these numbers are there. So only 1. 1 is the common factor. That means the highest common factor is also 1. So let's write the answer to this question, which says, what is the HCF of two consecutive odd numbers? The HCF of two consecutive odd numbers is 1. Question 3. The HCF of co-prime numbers 4 and 15 was found as follows by factorization. So they found the prime HCF of 4. So the prime factors of 4 will be 2 into 2 and 15 is 3 into 5. Now the question is, Since there is no common prime factor, as you can see, nothing is common, isn't it? For 4, what did they get? For 4, they got 2 into 2. And for 15, what was it that they got? 3 into 5. And as you can see, there is nothing that is common. There is no prime factor that is common. So the question is, since there is no common prime factor, so HCF of 4 and 15 is 0. So they're saying since there is no common factor, can we say that HCF is 0? Is the answer correct? If not, what is the correct HCF? Now, two co-prime numbers. Two co-prime numbers means numbers that have only one as a common factor. Okay, so co-prime numbers always will have their HCF as 1. It will never be 0. So if there is no common prime factor, the HCF will not be 0. The HCF will be 1. Let's write that down. So no, the answer is not correct. So here they are saying HCF is 0. Is the answer correct? No, the answer is not correct. If not, what is the correct HCF? The correct HCF is 1. So keep that in mind. For all co-prime numbers, the HCF will always be 1. So if you don't find any common prime factor between numbers, the answer is always 1 as their HCF. So with this, children, we come to the end of this exercise. Thank you, children.